I'd like to welcome everyone to our webinar. This is ATTO Technology. I'm Michelle Seifert. Matt Mercurio today will be presenting NVMe, our overview about the technology and how ATTO is supporting this. So at this point, I'll pass the webinar over to Matt Mercurio. Oh, and one bit of housekeeping. At the very end of our webinar today, we'll have some moments for questions and answers as well. And we'll be recording this. We'll send out a copy after. So Matt, I'll pass this over to you.
Thank you, Michelle, and good afternoon, everybody. As Michelle mentioned, we were just going to give a high-level overview of the NVMe technology to give you an idea where this technology is moving forward in the marketplace. First, a little education on what is NVMe and the terminology used. Many of you, and actually most of you, are all familiar with system memory, what's used in your laptops or your workstation or your servers. That's known as DRAM, or dynamic random access memory. It's very fast, but the problem with it is that it is not retained when the power is lost. And there's very little error checking in this technology. It's not really necessary. Then there's NVM, or non-volatile memory, and this differs from DRAM in that it retains the data after the power is removed. It includes magnetic storage, such as hard disk drive platters, tape, EEPROM flash, 3D XPoint, and RERAM. It does provide extensive error checking and very reliable. Now, what makes the storage drive is the interface and the media. The media being the, whether it's a hard drive or a non-volatile memory drive, and the interface being whether it's SAS or SATA to connect to that to that media. So a hard drive, as you can see, is the solid magnetic rotation media with SAS or SATA. SSD is your memory, NVM memory with SAS or SATA today, or as we'll discuss through this presentation, PCI Express. Tape drives are typically SAS, SATA, or fiber channel with tape. So you get the idea there. So what is NVMe? It's basically non-volatile memory express is what it's called, and it's a protocol for interfacing with that non-volatile memory, also called flash. So today you can actually buy NVM drives with SAS or SATA, but you can also get an NVMe drive, which is PCIe based. So it's similar to SAS and SATA and fiber channel. It's just a new protocol that reduces the latency between the memory and the media itself. It does this by using the physical layer PCI Express, as you'll see moving forward. Oh, another key important is all the OSs. NVMe does define an application layer on top of the PCIe, and what this allows is that the operating systems can build a driver in to automatically recognize NVMe drives. And you'll find a list of the operating systems that support this in a later slide. But this is important because it gives you the same functionality as you would a SAS or SATA drive, where they have the SCSI layer in the operating system to recognize those drives. Why NVMe? Pretty simple and straightforward. SAS and SATA was designed for spinning disks, hard disk drives. It was never really optimized for SSDs and the low latency and high performance that those can provide. As you know, hard drives have reached their performance limits, and you probably have many customers who need higher performance than the spinning disks can provide, and that's where SSDs come into play. But you can't get the full potential of those SSDs using in SAS SATA technology. So in comes NVMe, where it cuts out the middleman. It cuts out that SCSI layer that adds that overhead. it reduces the latency, and it lowers your CPU utilization, and it's just much more efficient. It is not used in hard drives or tape because there's really no benefit to that. A hard drive would be your bottleneck in that case. So to give you an idea of what today's performance looked like, as you know, a 12 gig SAS-PHY interface is about 1,200 megabytes per second, where an NVMe interface today is about 4,000 megabytes per second with PCIe 3. And with PCIe 4 coming out shortly, that doubles it to 8,000 megabytes per second. When you look at the drives themselves, a SAS hard drive can hit about 300 megabytes per second or 850 IOs per second, where an Intel Optane SSD can go about 2,500 megabytes per second and almost 500,000 IOPS. So you can see the benefits of using NVMe drives versus SAS hard drives. But as it says on the bottom, don't panic. Everybody is not going to just drop their SAS and SATA hard drives. It's not going away. These NVMe drives are expensive because they are not the most common interface on the market today yet. And there are still some obstacles that we'll talk about later with NVMe. Here we're just giving you an idea of the cost comparison. And as you can tell, the SAS hard drive and the SAS SSD is going to be a lot less than your NVMe SSD right now. So you really only see NVMe drives in large amounts in the data center. You do see them inside smaller all-in-ones and laptops today as well, but it's because of how much space they can save when compared to a normal hard drive or SSD. What you'll find over the last year is that the market is shifting away from the spinning disk and moving more towards the SSD. So the SSD market has quadrupled over the last 5 years compared to the hard disk drive market, which has brought down the price of flash drives, making the SSDs more affordable. Add to that the capacity of SSD drives have increased to almost match, if not exceed, the spinning hard disk drive. So it's become more cost effective to go to SSDs in many cases. So how do you connect these drives to your system today? There are 3 primary ones that people use. There's the PCIe connector, where an SSD drive literally just plugs into your PCI slot. This can give you your performance and capacity. These PCIe NVMe cards are very large capacity drives, but they can be expensive. The only problem is scalability with these. The second is the U.2 connector, which is also known as SFF8639. They can do typically by 2 or by 4 PCIe, depending on the whether it's an enterprise level or consumer level NVMe drive. The connector itself is very similar to a SAS connector. Finally, there's the M.2 connector, which you typically find in small all-in-one systems because this is a small form factor, easy to plug right into the motherboard and fit into a small space. Another option that Intel is working on is what they call the ruler form factor, SFFTA1002 for servers. Again, this is designed to address the scalability difficulties that you run into with NVMe drives. So how you might see connectivity in a server as well is similar to this picture. You would have a backplane with the SFF8639 type connector. It's, like I said, just like a SAS connector. And then you have cables going off, either connecting into the motherboard which will have connectors directly on there, or you can use a PCIe expansion card for NVMe devices, where some manufacturers have released this type of product. One type of connectivity that you may be more familiar with for NVMe is similar to 12 gig SAS. It's the HD Mini SAS connector. It's been slightly modified to handle NVMe drives, so it is different than a SAS cable, but the connectors look and feel exactly the same as the HD Mini SAS. This solution predated the Oculink that we talked about in the previous slide. So, as I mentioned in the previous slide, besides having the connectivity directly on the motherboard, there are PCI expansion cards that allow you to connect NVMe. In fact, they are combined SAS SATA and NVMe all in the same adapter. So it's tri-mode 5 configured for either NVMe or SAS SATA. You can't have an NVMe and SAS SATA on the same connector, but you can do, say, one physical port as NVMe and the other physical port as SAS and SATA. So one of the difficulties you have with NVMe drives is it's a one-to-one relationship. It's a direct attach. You plug it into a PCI slot and it eats up that whole slot. You can't plug multiple drives in there. So how do you get around the scalability limitation of PCI Express? We do that through PCIe switches. And so this is what you'll see in larger solutions as they start coming out. With many NVMe drives in one enclosure, they'll use a PCIe switch that connects directly into the CPU and allows you to connect more drives than there are lanes in your PCI bus. Another limitation is distance. PCI Express doesn't go very far. So in cases where you need to come outside the box and go a little bit further, you can add a link extension device to make that signal be retimed and be able to go the distances that are needed. Where is NVMe today? You can find it in a lot of storage servers, either right on board, the motherboard, or in this case, we're showing you they have 24 NVMe drives connected into a backplane, which then either connect either to the motherboard or an expansion card in the back of the chassis. These drives tend to be shared through Ethernet. This example shows 40 gig Ethernet, and again, we'll talk NVMe over fabrics later on, but that's how all these drives get shared outside the box. It is typically used as cache and mid-range storage arrays and storage servers because it's so fast and the latency is so low. But as I mentioned earlier as well, it's not only in these storage servers, you're starting to find them in all-in-one systems. In fact, the Mac Pro uses an NVMe drive inside it. So some of the features of NVMe. First and foremost, it's simple and efficient command set. When you look at the SCSI command set, it's hundreds and hundreds of commands. You know, a good section of that are mandatory. It adds complexity to the command set, where NVMe only has 13 mandatory commands, and they're basically administrative and NVMe-IO command type. It does provide namespaces, which is similar to SCSI logical unions for management, and it does support namespace sharing and multipathing, but it's not for storage area networks. It's just for redundant paths. It does provide the end-to-end data protection, as well as the features on the bottom where you can do reservations, firmware updates, data set manage it, and sanitize. So basically, the core commands that you need to function with making sure that your data gets to and from the storage in a secure manner are supported in there, and it reduces the latencies and the CPU processor time needed to process commands. Another neat feature of NVMe is its really large queues. It's got end-to-end I/O parallelization, on multiple CPU cores, and it's 64,000 I/O queues and 64,000 commands per queue. When you compare that to SAS, which only supports 256 commands, and SATA only 32 in a single queue, what this allows us to do is you can stack up more and more commands. Because the interface and the media are so fast, they can handle this many commands queued up to them. This is how they maintain the high performance that they can provide. There are some realities, some limitations, and we talked about these earlier. It's direct attach, it's inside the box. It's a one-to-one relationship, and there's only so far you can go without repeating the signal. So you can lead to wasted compute power when adding storage capacity. So what people desire is a way to be able to scale out NVMe storage and share it to multiple hosts and clients. One of those ways is through storage area network. The other way is through network attached storage. What we'll talk about here is, and how this is done, is how that storage is shared over fabric. Either fiber channel or Ethernet is a technology they added on was NVMe over fabrics. Again, it was designed to increase the scalability, and the options include fiber channel, InfiniBand, and Ethernet through Rocky or iWarp. What it does is it extends the NVMe protocol, and it's able to transfer that protocol over the fabric now. It addresses the scalability of NVMe, is really what you need to take away from FCOV in this matter. One of the things to keep in mind that we've found is fiber channel is better at maintaining or keeping the low latency and providing a guaranteed bandwidth that is necessary for NVMe. We think it's better than Ethernet because Ethernet can add latency through the TCP stack. Unless you're using a full RDMA solution in Ethernet, you will have added latency through the TCP stack. So ATTO believes that fiber channel is a better option if you want that guaranteed bandwidth of that NVMe drive. So it will be a gradual transmission. The industry is not asking all the users to go out and throw out their fiber channel storage and then turn everything into NVMe. With the use of a Gen 5 or Gen 6 fiber channel switch, you can actually mix NVMe over fabric devices with traditional fiber channel devices on the same switch. You do this through zoning. For the fiber channel HBA, you must use Gen 6 space, so it's either 16 gigabit fiber channel or 32 gigabit fiber channel. And to be able to talk via NVMe, you do need a storage array that supports NVMe frame types, whether it's an all-in-one NVMe over fabric storage array or a storage server with the fiber channel adapter that supports NVMe over fabrics in target mode. Here is just a general roadmap picture of NVMe technology over the years. As you can see, we're pretty much just had NVMe over fabric released last year, And this is why ATTO started looking at NVMe over fabrics in their own products and will be releasing in early 2018, and we'll talk about that later. 2017 and in the future, they're adding all the extra features, whether it's virtualization, sanitized boot partitions, support for all the different areas that SCSI already supports are being added into the NVMe protocol in the future. But as far as the base technology of NVMe and NVMe over fabrics, the drivers are there in the operating systems and ready to go. Now you just need the manufacturers like ATTO and your storage vendors to be releasing their NVMe over fabric driver and storage arrays. NVMe is supported in pretty much any operating system out there today, from Windows 7 and above, to Linux kernel 4.8 and above, VMware vSphere 5.5 and above supports NVMe drives, and all the other ones. Mac OS was probably the last one to add support, and I think that was with Mac OS Sierra was the first one to support NVMe drives. NVMe over Fabric was supported in Linux kernel 4.12 and higher. Over Fabric NVMe is not supported in Windows or Mac OS yet. So Fiber Channel NVMe support is actively being developed in various releases, including Red Hat and CentOS 7.4 and Fedora 26. And even Ethernet RDMA is getting more attention. Like I said, in the data centers, they can use that already with certain Ethernet vendors. NVMe over Fabric on VMware is on their roadmap for 2019. So where does ATTO fall into NVMe? First and foremost, we're going to be pushing, because we're experts in fiber channel technology, we are adding support for NVMe over Fabric and our fiber channel adapters first. This will be early 2018. By the end of Q1, we will release drivers and firmware that do support NVMe over Fabric, both in initiator mode and target mode. As I mentioned before, it will only be Linux drivers because Windows and Mac OS does not support NVMe over Fabric yet. The models of HBAs that will support this new driver and firmware are listed right there, including our 16 gig single, dual, and quad channel and our 32 gig single, dual, and quad channel HBAs. ATTO is also actively researching other efforts as far as NVMe as well, including adding support to NVMe in our future 12 gig RAID product, as well as our storage controller line, Extreme Core, of doing NVMe to conversion to Fabric, whether it be 25, 50, 100 gig Ethernet or 32 gig fiber channel. So what do we take away from today's training? NVMe is definitely growing. It's in the early stages though, and so the cost is very high and the challenges are still there, especially with scaling. SAS is not going away. 24 gig is on the roadmap. ATTO is planning to release 24 gig SAS HBAs. It's not going away. There's still a need for it, especially when it comes to tape drives and optical drives. There's not going to be NVMe support for those type of technologies. Excuse me. ATTO's first play, like I mentioned, is NVMe over Fabric, and again, this just follows how our expertise in fiber channel. After fiber channel, we will be doing NVMe over Fabric for Ethernet, and then, of course, we hope to have it for SAS and SATA RAID as well. The word no is not correct in this presentation. There is not a lot of NVMe over Fabric-based mainstream storage today. The OEMs and the storage manufacturers are starting to feel out and make their plans for for their storage for the future and to support NVMe. So you really won't find too much NVMe over Fabric in the channel today, just in the data center. You'll probably see NVMe over Fabric storage servers before you see all-in-one NVMe over Fabric storage boxes. Although I believe TGO is one that has an all-in-one storage over Fabric box today. And that is it for today. So if there's any questions.
This is Michelle again. So at this point, what I'd like to do is take a couple seconds and allow questions to be typed in. I think Matt presented a lot of material, so there's a lot to think about. You can always contact us on your own later by email as well. I know when I went through this presentation myself, it took some time before I actually, it sunk in and I thought about it, came back with questions. We'll just take a quick second. Matt, I see one that just came through, and I do think you covered this, but it's a pretty good question. Do you need a host adapter? Do you need an HBA in this type of solution?
Well, that again depends on the type of configuration. If you're talking direct attach NVMe to your system, if the motherboard has an NVMe connection right on the board, then no, you don't need an add-on card. Otherwise, you would. You would have to get a PCI expansion that supports NVMe drives. As far as NVMe over Fabric, yes, you do need an HBA that does support NVMe over Fabric, and it would be either fiber channel or an Ethernet adapter in that case.
All right. That was all the questions that we had. I think the takeaway that we'd like to make sure is everyone understands that this is a newer technology out there, and ATTO will be supporting it. Again, right at the moment, Q1 with our fiber channel, and then going on from there. Again, if you have any questions, please feel free to contact us at any point. And thank you very much.